Welcome to April 11th LeetCode Challenge. Shift 2D grid. Given a 2D grid of size m by n and an integer k, you need to shift the grid k times. In one shift operation, shift an element at index ij at the grid moves to ij plus 1 position. A grid element at I n-1 moves to a I plus 1 next 0 position, and a element at m-1 n-1 position moves to a 0, 0 position. Return to 2D grid after the operation has been applied k times. So these three components here just basically are mean that, for instance, you're given a m by n matrix here, and it's saying basically if a shift of 1 for this matrix, meaning that the last number at the m minus 1 n minus 1 goes to the first position, so everything else is moved to the right, and then 3 goes to 4 right here, and 6th position goes to the basically the I plus 1 position as well. So that's pretty much how the shift kind of works in terms of visualization. If we can visualize this one right here, we shift this k equals 4 times. So if we do this k equals 4 times, that means that 3 would be the row. Basically, all the rows would be shifted. This number 3 right here will be shifted to the 19 where it is, and we can see that everything from the last row moves to the top because the length of the columns is 4, so everything is moved basically 4 times. And then if we do basically this same matrix right here, and we have k equals 9, then we return the original matrix because the 9 is shifted 9, every single element is shifted 9 times, therefore it returns the original location. So the length of the grid is m, the length of the columns are n. We have m being between 1 and 50 and n being 1 and 50. The index, the actual values is negative 1,000 to 1,000, and k is between 0 to 100. So there's a couple ways of doing this. Let's go for the easy way first. So if we were to use NumPy, let's see if this works. Roll grid k times. Let's see if this works. We're gonna have to import it. Let's see. Import NumPy. So this roll in NumPy, this roll function in NumPy basically gives us back this. This is the actual function for it. Let's run it to see if it works, and I'll give you another solution, a more correct solution. All right. So this is a cheat way of doing it. Basically, you have a NumPy function, and the actual description here is basically the roll function for that built-in library. All right. Well, another way of doing it is that you could basically what's called flatten the matrix. Is the term where you basically change this two-dimensional array to a one-dimensional array, and then apply your shifts, and then shift it back into a two-dimensional array. So we're going to do that. We're going to change a 2D grid into a one-dimensional array. Then we just take a slice of where we need to go, depending on the columns, and then we shift the items, and we just put it back into a one-dimensional array, back to a two-dimensional array. And that's kind of a brute force approach of it too as well. So say we have something called rows and columns, and then we were to get the size of it, so the length of the grid, and then the length of the grid at size at index 0. This is the rows and columns. Then we have k will be the, we'll take the augmented modulus of the rows and columns, column times row. And then what next we're going to do is basically assign basically the grid to be, so in order to save memory, we just basically use the same variable and just kind of reassign it to be x for row in the grid for x in row. So we flatten the curve. Next thing you want to do is basically flatten the curve, meaning we take the entire grid and we just basically take this element here, 1, 2, 3, 4, 4, 5, 6, and just put it all into one array. Next thing we want to do is take the slices of the grid and then basically apply your application to it. So grid equals grid at -k slicing plus, so because we need to shift it by k amount, so we just take the slice of -k, 2 plus the grid at k to -k. Once we have all that, let's take the grid and we are going to put it back into a two-dimensional array. So we take the grid at the, let's see, we'll take a variable, say, for each row r. Actually, take r out of here. Within the scope, and keep it there for r times column slice from the row times the column plus column. So that's the first for each column. Now I need to make the rows for r in the range of row. Hopefully this first return grid. Alright, yeah, so let's submit it. I'm hoping this works. Excellent. It's a bit quicker. So basically what we did was we found the length, the size of the grid. We took the k with modulus from the row and column to find the slicing dimensions. So then we just shift each element using slices, and then we put everything in a two-dimensional array. So time complexity is big O of n due to the this list comprehension here. Space complexity is big O of constant space because we just pretty much just manipulate the grid in time. All right, that is all. Have a great day, guys.